Quick Start Tutorial. Wave equation on a circle. This tutorial explains how to set up and solve a generalized wave equation model on a unit circle. The wave equation is a hyperbolic partial differential equation, with second-order time derivatives, which prevent usual time-stepping schemes to be applied. However, the problem can be transformed and solved, as done here, by instead reformulating the wave equation as two coupled parabolic PDEs. This tutorial can be run by selecting Model Examples and Tutorials, Quick Start, Wave Equation on a Circle, from the File menu, and followed with the step-by-step instructions in the user's guide. To start a new model, click the New Model toolbar button, or select New Model from the File menu. In the New Model dialog box, first click on the 2D radio button in the Select Space Dimensions section, and select Custom Equation from the Select Physics drop-down menu. Leave the space dimension names as x and y, but change the dependent variable names to u and v. This will enable the two parabolic equations for the transformed and coupled wave equation problem. Finish and close the dialog box by clicking on the OK button. Geometry mode. The geometry consists of a unit circle with radius 1 centered at the origin. Select Circle from the Geometry menu. Enter 00 into the center edit field. Enter 1 into the radius edit field. Press OK to finish and close the dialog box. Grid mode. Switch to grid mode by clicking on the corresponding mode toolbar button. The default grid may be too coarse to ensure an accurate solution. Decrease the grid size to generate a finer grid, which is able to resolve the curved boundary better. Enter 0.1 into the grid size edit field. Press the Generate button to call the grid generation algorithm. Equation mode. Switch to equation mode by clicking on the corresponding mode toolbar button. Equation and material coefficients are specified in equation subdomain mode. Set the initial condition u0 to 1 minus the radius, and v0 to 0. Then click on the Edit button to open the equation editing dialog box. In the Edit Equations dialog box, enter the two coupled equations in the corresponding edit fields for u and v. Press OK to finish the equation and subdomain settings specification. A convenient way to define and store coefficients, variables, and expressions is using the model constants and expressions functionality. The defined expressions can then be used in point, equation, boundary coefficients, as well as post-processing expressions, and can easily be changed and updated in a single place. Click on the Constants toolbar button, and enter a new constant named c, with a value of 1 for the wave speed. Press OK to finish. Boundary mode. Press the Boundary Mode toolbar button to change to Boundary Condition Specification mode, and select Dirichlet conditions with a fixed value of 0 for all boundaries. Solve mode. Switch to Solve mode by clicking on the corresponding Mode toolbar button. Press the Settings toolbar button to open the Solver Settings dialog box, select the Time-Dependent Solver Type option, and set the time step to 0.05. Press the Solve button to start the solver with the chosen settings, or press OK and then the toolbar button with an equals to sign. Post-processing mode. The solution at different time steps can be visualized by selecting the corresponding solution times and plot options in the post-processing settings dialog box. Press the Plot Options toolbar button. Select the Enable/Disable Height Plot checkbox. Select 0.65 from the Available Solutions Times drop-down menu. Press OK to plot and visualize the selected post-processing options. To create an animation or video of the solution, one can use the Animate Playback Solution option in the Post menu. The tutorial is now complete, and the model can be saved as a binary file, exported as a MATLAB M script file, or a GUI playback file.